Good morning, professors, Mr. Chua, teachers, and friends. Today we'll be presenting about control and operation of a large-scale distillation column. Okay, our group is a bit different because our three subgroups actually did with different variables, so we all combined to make this presentation rather than one group doing it. Introduction? Okay, so distillation is basically a method used to separate different components in a solution, liquid solution. Okay, distillation is used in various ways, such as distilling water, crude oil, and air. Okay, there are basically four main objectives for our project. The first one is to investigate the steady state of distillation of a binary mixture under continuous operation. The second one is to see if the effect of reflux actually affect the performance of the distillation. The third one is to measure the chemical composition, which is ethanol and water, using gas chromatography. And the fourth one is to operate distillation column based on product requirement. Okay, so we use the distillation column to separate the water and ethanol components from the mixture.
This is a diagram representation of the distillation column. The distillation column can actually be as wide as 10 meters in diameter. There's a different range of scale. So this is a smaller size of an industrialized distillation column. So first of all, the thing that you need to know about distillation column is actually the feed tank. The feed tank is actually this glass beaker that holds the original feed. Feed is actually the component that you need to distill. Crude oil is actually the thing that you need to distill. The thing that you need to distill. So crude oil is the feed. This is actually the top product receiver. The top product receiver is actually the container to hold what you have distilled in the end. So in our experiment, we actually need to distill the mixture of ethanol, which is the alcohol, ethanol and water. So in this top product receiver, the liquid that you will found there has a richer content of ethanol. The reboiler is actually another storage for the feed, but it has a heater behind it to provide heat. This is the distillation column, as in the column where you can see the actual distillation happening and the evaporation. You can see the thing is boiling and the vapor will slowly rise up. And this is actually the entire distillation column machine, and you can see all the parts that I had just mentioned. The three parts that I have mentioned just now are the main parts that you must know in order to do distillation.
Okay, hi everyone. Remember last year we all did an experiment on distillation? Okay, so the first diagram is the distillation diagram that we did last year. The second one is the chain one that we are doing. Okay, so the new things that we are learning. Okay, first I'll say the one that we did last year. Okay, in SST we did simple distillation, and we have one column, the whole thing with no trace. We used dyes and water, and we separated the pure water from the solution, and we only used a few milliliters of water. For NTU, it's actually a huge multi-scale distillation column, which means there are many more apparatus that we will be using, and there are many trays in the column which condensation occurs. We also, for our solution, we use water mixed with ethanol. And instead of using a few milliliters, we use 20 liters.
Here are some real-life applications, and these are the examples. In the brackets are the products being produced from the distillation process. In crude oil, kerosene, naphtha, and many other substances are being produced. And I'm going to talk about it later on. And extracting of essential oil from plants are to produce food colorings such as citric oils and as well as other liquid forms. And perfume, purifying water are also some of the examples of real-life applications. Air separation is to obviously extract oxygen, which is needed for us, from nitrogen and argon and many other gases as well. Alcohol processing is to process liquors like vodka or whiskey, so it's like it is easier to get the pure substance. Now moving on to the crude oil. As we learned from science last year, different substances have different boiling points. So for refinery gas, the boiling point is at 20 degrees, so it will be melted, it will be boiled first, and bitumen will be the last, which is at 340 degrees Celsius. For the bitumen, you may think that we will just end it like that. However, we will continue on with the distillation process, and end up bitumen will also the end product of bitumen will also become the first wall on top.
So, bam. Okay, so our first task that the professor gave us was actually to blow up the column. Yes, to blow up the column. He gave us a challenge, so challenge accepted. So straight away we went into looking through the factors that might affect something that blows up. So basically in a column there's only 4. But high pressure explosive liquids heats and manipulating the valves. We'll skip explosive liquids because that's illegal. There are some pictures, that's the valve, that's the reboiler, and that's something to do with pressure. Yes. So technically, what causes pressure in a distillation plant would be the heat. The more heat you have to pump up, more amount of water gives you higher pressure. Oh, so this is my teammate will be talking about how to manipulate the valve.
Okay, so that black thing over there is a valve. So a valve is the use of the valve is to regulate the flow of the liquid. When closing the valves, the liquids have no place to move. As vapor is rising up, the same time the pressure increases. Okay, so what we have learned from this was that during the experiment, we are supposed to keep all the valves open so that the pressure will not increase, and to decrease the rate of the pumper because, so that the pressure is not that high. And in order to make it explode, we have to close all the valves except for the feed tank, so that liquid will be collected in one place, and you explode an explosive liquid, and to turn the temperature of the liquid to maximum. So now that you know how to explode the color, so maybe one day you can just pop in and say, oh hi, I want to explode. Okay,
talking about the various equipment that we use along with the distillation column so that we could carry out our test. Okay, the first is the manometer. The manometer is a device that will measure the pressure in the distillation column itself, and the valves connected to the manometer are always closed except when you want to test the changes in the pressure. Okay, the next is the main control panel for the distillation column. As you can see, there are 5 different parts to it. The first part is the reflux. The second is the temperature, the amount of energy sent to the reboiler heater. The third is the feed pump, and the other 2 are changes that are made when you make physical changes to the distillation column itself. Okay, so this is a diagram of the control panel that is connected to a computer, and the computer will show the temperature of each part of the distillation column updated in real time. The other part will be the graph in the control panel, which will show us if the temperatures in the column are equilibrated. The reason why we need these temperatures to be equilibrated is so that we can carry out tests on the purity of the alcohol without any changes. Okay, so the next is the gas chromatography machine, which is what we use to test the purity of the alcohol. There are a few parts to the gas chromatography machine. Okay, the top represented by the green arrow is the injector port, which is what we use to insert the needle in with 0.1 milliliter of the sample that we use. On the left is the carrier gas, which is used to test the purity of the alcohol, and on the right hand side is the recorder.
So for our experiment, what happened is that we uses ethanol and water. So different atoms moves at different speed. When you put a sample into the gas chromatography, it actually heats it up. Pressure builds up. It spins around the column in the column oven. So since the atom that is smaller or faster moves faster, we can tell the difference between different types of atoms through the detector over there. This is one of the most precise way of finding out percentage and concentration in water. Well, this is all. So the difficulties we have encountered, it started throughout when we received our manual. We flipped through it and we saw tons of words in which we have no idea on. But once we reached the lab, we were more relaxed, because what our professor actually first said was that you can forget about all that. You won't be learning that well because you yourself will be coming up with the formulas. So actually that set our minds at rest. Other difficulties we have faced would be, actually one of it was trying to blow up the column, which we didn't really succeed. So throughout, actually we do not have much difficulties beside those, especially we learn more about teamwork. So our team was actually very cooperated in helping us achieve our objectives. And so this is all that we have for you about distillation, and hope you enjoyed it. Thank you.